Hey everybody, this is going to be a long one. All we have to do is find all the zeros. So, we're going to start like a pig, I guess. Start rooting around for roots, digging for roots, like a pig hunting truffles. And much like a truffle hunter, that's the analogy I'm going with. We're going to use all the tools at our disposal. We have the rational zero theorem, Descartes' rule of signs, and if we get really stuck, we can use some graphing tools. We don't always have graphing tools, so I'd like to try to solve these without graphing tools. What I want to do is I want to start with the rational zero theorem. So I'm going to look over here at 1 and I'm going to look over here at 10. So that's going to give me my possibilities of plus or minus 10. Actually, I'm going to list them all out individually. So my possibilities are 10, negative 10, positive 5, negative 5, looking at the ratio of the factors of 10 and 1. This should be plus 2, negative 2, plus 1, minus 1. Alright, and I'm just going to start doing synthetic division using these until we find them. So let's start with 10 and let's divide it into 1, minus 4, minus 7, 10. Alright, so 1 times 10 gives us 10. This gives us 6, 60. Uh-oh, we can already see that it's not 10. So let's try again with negative 10. And again, we're just using a little synthetic division here to try and see if we're going to get what we need. So that's negative 14, positive 140, 133. Yeah, this isn't going to work. Negative 1330, negative 1320. That's not it either. So it's not 10 or negative 10. Let's try positive 5. 1, minus 4, minus 7, 10. Bring down the 1. 5 times 1 is 5. Negative 1. This looks promising. 5 times negative 1 is a negative 5. Nope, never mind. Signs are wrong. It's a negative 12. So this gives us a negative 60. So that's negative 50. Nope. And remember, we need that division to divide out cleanly and to give us a remainder of 0. If nothing else, we are absolutely going to be certain of how to do synthetic division on this polynomial by the end of this. So that's negative 5. Nope, see, this isn't going to work either because we're going to get negative 9. And this will give us 45. We need this to end at like 2. And that's not going to happen. 45 minus 7 is 38, so negative 190, negative 180. That's not it either. Looks like we could have saved ourselves some trouble by starting at the other end of this, huh? Let's try plus 2. 2, and then 1, minus 4, minus 7, 10. Let's divide this out. So we'll do 1 times 2 is 2. This will give us negative 2, negative 4, negative 11, negative 22, so negative 12. Nope, it's not 2. Negative 2 maybe? And we really should have started at the other end. Negative 2 dividing into 1, minus 4, minus 7, 10. Bring down the 1. We multiply. We get negative 2. This is negative 6. Positive 12. Wait a minute here. So this gives us 5. Negative 2 times 5 is negative 10. Haha, that's a 0. We've found it. Great. Now, since this is cubed, not like to the 4th power, I'm not going to keep going and looking for other roots. And even if it was to the 4th power, I think I'd write it factored out as, so the root is -2, so that's x plus 2 times x squared minus 6x plus 5. Great. And oh look, oh, I know exactly what's going on with this. Look at this. You get one little edge, and then suddenly x minus 5, x minus 1. Absolutely, that's how that factors. So we've got this polynomial all nice and factored. So the zeros, x is equal to -2, +1, +5. Great. Look at that. Excellent. So just a bunch of rounds of synthetic division and then a little bit of factoring. And we were able to get our zeros, or our roots. I usually call them roots. Great. I'll see you next time for some more of this.